Yeah, so hi, I think we are meeting for this live, it's like your third or fourth kind of live masterclass, right? Okay, so let us start the class with a question. So guys, the questions that I'll be posing to you will be based on the concepts that you guys have been seeing and learning, and let us just see how we can apply them clearly, okay? So let's say I give you an integer array of size n, okay, and this array is sorted. It is guaranteed that the input is sorted. Now sorted in which order? It is sorted in non-decreasing order. So what do I mean by non-decreasing order? Non-decreasing order means that if the elements are a0, a1, a2, so on till an minus 1, then this property must be there. Non-decreasing means never decreases, either increases or stays the same. So you could have something like 5, 5, 6, 7, 7, 7, 9, 100. Yeah, so this is a non-decreasing array. That's your input. Now what is the question? Let's try to understand that. So the question is that you have to create another array. See, you have to create another array, call that as result array. So you have to create a result array of the same size, which is n, okay, of the same size, such that, so now I'm going to tell you that, hey, you have to create another array result of size n, such that result of I must be equals to sum of absolute difference between array I and every other array element. Okay, so I think that's a lot of text. Just go through it. So you know what is the first step of problem solving? The first step of problem solving is clearly understanding the problem description. So the problem description is on the board, read it, and then I'll come to the picture and I'll help you understand if you could not. It's not a very difficult question, by the way. If you just read through the lines and also take an example, the things will become very apparent to you. Okay, let's take an example. Okay, look at the board. So let's say you have been given this input array which is sorted, and let's say this array contains some elements, and those elements are, let's say, A, B, C and D. Of course, they will exhibit a non-decreasing order. Okay. Now what I want to do is that I want to come up with a result array, as the question says, which should be of the same size, that is size 4. So there should be 4 items inside this. Okay. And now result of I. So let's say if I talk about this, what is this? This is result of 2, index 0, index 1, index 2. So result of I should be equals to sum of absolute difference between array I and every other element of the array. So if, let's say, this is your reference element, if this is your result I, then this is your array I, right? So if this is your reference element, then you have to consider the sum of absolute difference between array I and every other array element. So think of it in this manner. You have to take into account the absolute difference of C and D, which will be mod C minus D. You have to take into account the absolute difference between C and B and between C and A. Done, right? So apart from C, there are 3 more elements which are A, B and D, right? A, B and D. And you have taken the absolute differences with them, and whatever will be this sum, that has to come and sit over here. And whatever exercise you did for C, that you have to do for B also. So when you come here, the value over here should be the absolute difference of CB plus absolute difference of DB plus absolute difference of AB. Similarly, when you are here, the value that should come over here should be absolute difference of BA plus absolute difference of CA plus absolute difference of DA. So is the question clear now, that what is expected in the result array? Cool. So now that you have understood this thing, let's replace A, B, C, D by some actual values. So let's say this is 1, this is 2, this is 3, and this is 5. Can somebody tell me what will be the value that will come here? Yeah, 5, right? Why will it be 5? So first you will compute the absolute difference of 3 and 5, which is mod 3 minus 5. Then absolute difference of 3 and 2, which is mod 3 minus 2. And then absolute difference of 3 and 1, which is mod 3 minus 1. Yeah. And when you sum them up, so what is mod 3 minus 5? It is 2. What is this? 1. What is this? 2. And the sum of these is 5. So the value that should come over here must be 5. Okay, so now you guys understand, it's very easy to calculate, right? So if you just go ahead and solve this problem in a brute force manner, it's very easy to calculate. You just have to fix a particular element, and then for that element, you have to consider all the other elements and compute the absolute differences and keep summing them up. And whatever you get, that will be the value which will come and sit over here. Okay, let's take another smaller test case, and you guys tell me the output for that. So let's say I have in my input 2, 3 and 5. What will be the output of this? 4, 3, 5, yeah. So looks easy, isn't it? So I can say that, hey, the value over here should be absolute difference of 3, 2, that is 1, plus absolute difference of 5, 2, that is 3. So here I should be having a 4. Similarly here I should have absolute difference of 2, 3, that is 1, plus absolute difference of 5, 3, that is 2, so 3 must come over here. And when I talk about this, here I should have absolute difference of 5, 3, that is 2, plus absolute difference of 5, 2, that is 3, which is 5. That's how this is the output. Okay, now tell me, how many of you can solve this problem? Even in the brute force way? Using 2 loop, yeah? Good. That's perfect. So as we already agreed upon, that whenever, let's say this is your generic array, so whenever you fix an element, let's say a of I is fixed, then you have to consider all the other elements which are not ai, okay, and just keep on computing the value of absolute differences, okay, and you can keep on storing those absolute differences in some variable. You can keep adding them up, and then you can assign that thing to come and sit at this position in your result array. So the code would look pretty simple if you just follow this particular technique. So what you can do is that you can create a result array of size n, and then you can just iterate from I equals to 0 to n. So now in this process what you are doing is that in the ith iteration you are figuring out what should be the value of result of I. For that you need to consider all the elements other than ith element, and in order to do that you need a nested for loop inside. So you will say that you will consider all the elements j equals to 0, j smaller than n, j plus plus. And now what is it that you want to do? So let's say this was your element and your j started moving from here. So you will first compute the absolute difference of this and this, add that to a variable, okay? So that variable has to be declared somewhere outside. So I initialize int x equals to 0, and every time what I am going to do is whenever I compute the absolute difference of ai aj, I'll add that absolute difference to this x, correct? One more thing that I can take care of is that because I do not, now when you are moving this j loop, you will move to a value which is j equals to I also. So let's say your I was equals to 5, you will come to j equals to 5 also. So you do not want to consider that case, because if a particular element is your reference element, then you just want all the elements other than that to be considered while the computation of this particular thing. So you can have a simple check that if j and I do not match, then you will add to the x the absolute difference of ai and aj. This abs function, it exists in almost all languages, which takes a number and or expression and gives you the absolute value. Even if it doesn't exist, you can do it on your own, okay? So yeah, now in this process, the x will contain the value that should come and sit over here. So once this for loop is over, at the end of this for loop, you will just do result of I equals to x. Okay, Can anyone quickly comment on the time complexity? If the size of the array is n, yeah, very good. It will be n square. And why will it be n square? Very simple to comment. Because outer for loop is going to run for n times, and for every iteration of outer for loop, inner for loop is also going to run for n times. So it will be n into n, which will be n square. Now, this is done. This is brute force. This is n square. Can we do better? The problems on maths, one important thing about these problems, be it on arrays, be it on maths or any random coding problem, you have to observe some pattern, okay? And when you observe that, then things become very, very easy for you. Okay, so I'll pose a hint to everyone and that'll set things up for you. Okay, tell me one thing. How is mod of x defined? What is the value of mod of x? Let's say x is an integer. So what is the value of mod of x? So let's say you have mod of -5. What will that equal? That will equal 5, right? And if you have mod of 5, that is also equals to 5. Yeah, it's positive always. So guys, technically I can define it in this manner that, hey, mod of x will be equal to x if x is greater than or equals to 0, and it will be equals to negative of x if x is negative. Correct? And the same thing can be implied everywhere else also. So let's say you are considering two things, two numbers, a and b, and you are doing mod of a minus b. So how can mod of a minus b be defined? So let's understand that. Mod of a minus b will be equals to a minus b if a is greater than or equals to b. Because if a is greater than or equals to b, then the mod will definitely open with a plus sign because a minus b will be greater than or equals to 0. If you have 7 minus 2, then this is going to be equals to 5 only. But if you have something like 2 minus 7, then it is going to be 5 again, and this 5 is negative of this value because this value is minus 5. So mod of a minus b is equals to b minus a if a is smaller than b. These are just simple mathematical expressions. Do they make sense? Can it be helpful? This is the point from where you should start building your intuition. Can it somehow be helpful? How many of you feel it can be helpful to solve this question? Remember it that the array is sorted in non-decreasing order. That's a very important point to understand. So let's say this was my array, okay? Now focus on the board. Okay? Everyone should look here. Now this array is sorted in non-decreasing order, right? So let's say this is your original array, and now you want to build your result array. So your result array will be of the same size, 1, 2, 3, 4, 5, okay? Let's say you want to know that what should come here, okay? What should come here? So tell me one thing, you will consider the absolute difference of d with respect to everything else, okay? So there is a part that is in the right side and there is a part that is in the left side. So when you take the right side element and let's say you are doing mod of d minus e, mod of d minus f, can you tell me with which sign the modulus will open? Remember it that the array is sorted in non-decreasing manner. Because the array is sorted in non-decreasing manner, you could have had 2, 3, 5, 9, 10, 12. So when you do something like 9 minus 10, 9 minus 12, then what will happen? 10 and 12 are greater than this 9 because the array is sorted in non-decreasing manner. So this and this mod will open in this fashion. It will open like e minus d and it will open like f minus d. We just try to understand because e and f are strictly greater than or equals to this d. Does this point make sense to everyone? Okay. Now, how will the modulus sign of left elements open? So left elements are the modulus difference of dc, modulus difference of db, and modulus difference of dA. Because again the array is sorted, so I can say that hey, this d will be greater than or equals to them, so they will open with the same sign, which is this thing. Okay, does it look cool? Now your answer will be sum of these things, correct? This is what your answer will be. So let's do one thing. Let's take a pen and paper, everyone. Let's sum them up and see what you are getting. You will get something interesting. Let's sum these things that I have circled, sum them up on a piece of paper. Okay, what will you get? Let us understand that. You will get E plus F. See, when you add this and this, you will get E plus F minus 2 times of D. E plus F minus 2 times of D. And then from here, you will get 3 into D minus A plus B plus C. This is what you are going to get. Clear to all? I simply added everything that I have circled up, right? And I have put the brackets in the right manner. Why? You will understand that. So see, when you added this and this, you will get E plus F minus 2 times of D. And when you added them, you get 3 times of D minus A plus B plus C. Correct? Now tell me, what is this? If this is my D, then this is nothing but suffix sum. What is suffix sum? You all have already learned that suffix sum is sum of all the elements after this D. So this is my suffix sum. And can you tell me what is this? A plus B plus C? Yeah, good. A plus B plus C is prefix sum. Cool. So if this D is my current element, then this is my prefix. Okay? So this prefix sum, which is sum of all the elements before it, is being reflected over here. And this D is your reference element. This D is your reference element. Okay, now, what is this 2? Let's understand that. So tell me one thing. The number of times D will come, that will be equal to, listen to this line very clearly. The number of times D will come in this part will be equal to the number of elements after D, right? Because those many times subtraction is going to happen. So can you make this a bit generic? Is that possible? So if this index is I and this index is n minus 1, then how many elements are lying after index I? So after index I, the number of elements will be n minus 1 minus I. So this thing is equals to n minus 1 minus I. And see, what is your I here? Your I is 0, 1, 2, 3. So if you put I equals to 3 and if you put n equals to 5, then that is what you would end up getting. Your n is equals to 6. So this is what you would be ending up getting. So did everyone understand the generic value corresponding to this? Because this index is n minus 1, this is I, so the number of elements will be n minus 1 minus I. Right? Okay. Now tell me one thing. Here also D has a coefficient, okay? What is this? So the number of times D will come in this part, that will be equal to number of elements in the left hand side, correct? And if this index is I, see, be careful, do not give wrong answer. If this index is I, then how many elements would be lying in this part? See, take an example. Why don't you take an example? What is the index of D over here? The index of D over here is 3. And how many elements are lying before D? 3 elements. Good. So I can say that if this element is ith element, the number of elements in this part will simply be equal to I. Okay, cool. So, right? So guys, what I can say is that if I have to find what should come here, I can call that result of I. So my result of I will be equals to suffix sum, which is the sum of elements after I. So I'm going to write that as suffix sum minus number of elements after this index I, which is n minus 1 minus I multiplied by this particular element, which is A of I, plus this is the contribution of this part, okay, which is the contribution of right side elements, and for left side elements the contribution will be what? It will be I multiplied by array of I, okay, I multiplied by array of I minus something. And what is that something? That something is your prefix sum. So this is your generic expression for finding result of I. You just have to know the value of suffix sum and prefix sum. If you know the values of suffix sum and prefix sum at any instant, then you can very easily detect what your result of I should be. Does that make sense? Now once you know this expression, Do you feel you can solve this problem in order n? Right? It's going to be very easy, right? So you know that you can have a variable called as prefix sum, and you can maintain prefix sum while moving from here. So whenever you move, prefix sum will simply be equals to previous prefix sum plus the current element. That's how your prefix sum moves. And whenever you have a prefix sum, can you also somehow get to know your suffix sum? So of course you can use order n space in which you can have a prefix sum array and you can have a suffix sum array. But what I am trying to say is you do not really need those two arrays, because let's think of it in this manner. Let's say the elements are 3, 4, 5, 6 and 7. Okay. So when you are here, the prefix sum is known to be 7. If prefix sum is known to be 7, and let's say you know total sum also. If you know total sum, see, total sum is sum of the entire array. So is total sum going to change? Total sum is the sum of entire array. Is that going to change? No. You know the total sum, and if you know the prefix sum, can you somehow know the suffix sum also in a very easy manner? Right? What will it be? So I can say it will simply be total sum minus this. So it will be total sum minus prefix sum minus this element also, because I want to get rid of all these things, and this element I know, which is array I. So if I maintain prefix sum, then this is what my suffix sum would be. Now don't you think so? It has become very easy to code this approach. So one important thing about this approach is that I really did not need to store prefix sums and suffix sums somewhere, because I know that if I pre-compute the total sum, it will be very easy for me to get suffix sums if I am maintaining the prefix sums in a proper manner, which we have already learned how to do that. So let's come to the implementation part of it. So you will build this vector result. So I'm using vectors instead of using arrays. It's easy to manipulate vectors. And then I'll initialize a total sum to 0. And I'll initialize my prefix sum also to 0. Now my responsibility is to first compute the total sum, which I can do very easily by scanning the array, and total sum is not going to change. So what I'll do is I'll just move from I equals to 0, I smaller than array dot size I plus plus, and what I'll do is total sum plus equals to array of I. In this for loop, I have computed my total sum, right? Now I can write a separate for loop where I am finding out result of 0, result of 1, result of 2, so on till result of n minus 1. So now I'll move again from I equals to 0, I smaller than array dot size I plus plus. Yeah. So what will be my candidate? What is the expression that we guys have come up with? So although I erased that, but let's rewrite that again. So that was simply equals to this suffix sum minus the number of elements after index I, which is n minus 1 minus I, multiplied by a of I, plus, what was it? Plus this is going to come for I times, so I multiplied by ai minus contribution of this, which is reflected in prefix sum. So this is the value which deserves to be pushed in result vector in ith step. Okay, and doing that is going to be very easy. So what I can do is result dot push back, right? Now big expression will come, but nothing to get scared of because you know the concept, right? So what is your suffix sum? Your suffix sum is simply total sum minus prefix sum minus array I, and you are maintaining this prefix sum in the right manner. So it will be total sum minus prefix sum minus ai, right? And that minus this into a of I minus what is your n? Your n is equals to array dot size minus 1 minus I multiplied by a of I. Okay, a of I is like your array of I, and plus I into array of I minus prefix sum. Do not get scared by this. It's just a mathematical expression born out of pure logic. So now what will be the final step? The final step will be, because you have populated this result vector, so it's your responsibility to eventually return it, and your job is done. Okay. Yeah, very good point that we all missed out upon. So prefix sum is something which is to be updated in the end, correct? So once you have done this thing, once you have pushed the right thing in the vector, then finally you are supposed to update your prefix sum by this line of code. What's the time complexity of this approach, guys? Order n, right? And why order n? Because all of us can very clearly see that this loop ran for n times to compute the total sum, and even this loop ran for n times, and in every iteration it was doing some additions, some multiplications, some subtractions. They were constant operations. So n iterations, every iteration is composed of constant work, so it will be like order of n. Extra space, did I use any extra space? I did not use any extra space, right? See, this space is inevitable. Why it is inevitable? Because the question itself asks you to construct a separate array. So this is inevitable, right? But apart from that, I did not use any other array of size n or any other map of big size, okay, or something like that. Yeah, so what I'm trying to convey from here is that most of the times when you have such questions where you are not clear that what a value could be, and it looks like a mathematical one, pattern is something that always helps. I'll pick another question, okay, which will be even more interesting, and let's test our nerves on that, okay. By the way, this was a recent Amazon interview question, this one. Okay, so once again, I'm going to give you an integer array containing n elements. Now this is not sorted. Previously I told you, in the previous problem, the array, your input was sorted. Here it is not sorted, okay. Now what you have to do is, listen the statement of the problem first. So it says that for any non-empty subsequence, we have a term called as width. Okay, now before I go ahead and talk about what this width term means, let us understand what is a subsequence. What is a subsequence and how is it exactly different from a subarray? Subarray is contiguous and subsequence needs not be contiguous. So basically, subarray is a contiguous part. So if you have elements like 10, 2, 1, 0, minus 1, 3, then this is a subarray. It is a contiguous part. But if you pick elements like 10, 0, 3, then this is not a subarray, but this is a subsequence. So subsequence basically means that you pick this array, drop some elements, and then whatever remains, that is a subsequence. So the question says that for every non-empty sequence, there is a term called as width. And what is width? Width is simply equal to the difference between max and min, which is nothing but max minus min. So let's say you consider this subsequence, it has a max and it has a min. So whatever is the difference of max and min, that will be regarded as the width of this particular subsequence. So every subsequence has a width, every non-empty subsequence has a width, and this is how the width is being defined, right? So what is the width of this subsequence? 10, 0, 3. It is 10, right? So now let's talk about the actual question. Now every one of us know what is a subsequence, and every one of us also know that there can be multiple subsequences. So many subsequences are possible. Now for each of those subsequences which are non-empty, you determine their widths, you add those widths, and whatever you get, that is supposed to be your answer. So let's say that in a nutshell was the question. I'm going to write the question carefully now. So you have to return the sum of widths of all subsequences. So So you come up with all the subsequences, you figure out their widths, you sum those widths up, and that is what your answer should be. Okay, let's take an example. The best way to understand it is by taking an example. So guys, whenever sometimes you see a problem, you do not get it properly, the best way is take an example and then just do whatever the question is asking you to do. So I'll give you a very simple input. So let's say your input is an array containing 2, 1, 3. So can you tell me what will be the sum of widths of all subsequences for this input? Can you just tell me how many subsequences are there? Non-empty. How many non-empty subsequences are there for this input? 2 raised to power n minus 1. Okay, yeah, that is right. Okay, why not list them down? So see, my first subsequence will be where maybe I just have 1, then where I maybe just have 2, just 3, 2 and 1, 2 and 3, 1 and 3, and the final one will be everything, which is 2, 1, 3. Right? These are all subsequences. Okay, now let us understand how many subsequences can be there. So if you apply rule of product, you can say that for every element, so let's say I want to build a subsequence, then for every element there are 2 options. Either I can take it or not take it. So 2 options for first element, 2 options for second element, 2 options for next, and 2 options for last. And because there are n elements and 2 options for each of them, the rule of product will say 2 into 2 into 2 into 2 till n times, which will be like 2 raised to power n. So there will be 2 raised to power n different subsequences, and one of those will be an empty subsequence where you did not choose anything. But I am not interested in empty, right? So total number of non-empty subsequences will be 2 raised to power n minus 1, which is the case over here. 2 raised to power n is, your n is 3. There are 3 elements. So 2 raised to power 3 is 8, 8 minus 1 is 7. And you can see that there are 7 of them, right? Okay, now, you know, one mistake that some of the people do is that they regard 2, 1 as one subsequence and then they regard 1, 2 as another subsequence. Is that a correct thing to do? No, because the permutations of the same subsequence are the same thing only. So you are saying that you chose 2 and 1 and then you are saying you chose 1 and 2. Both are the same because the combination that you have is exactly congruent to each other. Okay, cool. So now that we have all of them, we'll be computing, widths. So what is the width for this? The difference between max and min. In this thing, max is also 1, min is also 1, so it will be 0. Max is also 2, min is also 2. Same thing here. Here the max is 2, the min is 1. Here the max is 3, min is 2. Here the max is 3, min is 1. And what about this one? Max is 3 and min is 1. So again it will be 2. And what is the sum? What is the sum of all of them? 2 plus 2 plus 1 plus 1, which comes out to be 6. Cool. So now you guys understand it very well that what the question is actually asking. It'll throw an array at you and then it'll ask you that, hey, consider all the non-empty subsequences, which is 2 raised to power n minus 1 different subsequences. Come up with their widths, add them up, and that is what I want to get. So is everyone now clear with the expected output from the given input? So how many of you can do it in a brute force manner? Can I say that brute force approach can be as simple as just creating all the subsequences. So you create all the subsequences, which you can do using recursion, which you'll be learning. And then whenever you have a subsequence, you can extract the min, extract the max, compute max minus min, add that to your answer. So this is a brute force work that all of us can do. Does that sound good to all? But don't you think it will have a lot of time complexity? Why? Because the number of subsequences is this, which is, I can say number of subsequences will be almost 2 raised to power n. And even if let's say my n is 10 raised to power 5, there are 10 raised to power 5 elements, my code will take 2 raised to power 10 raised to power 5 time to run, which is like huge. So I'll definitely time out. So this is not the approach that I would want to take for sure, right? Does it make sense to everyone that why this approach is going to cost a lot? Because the time complexity is simply exponential. Okay, if you run a code like that on your computer where you are generating all the subsequences and you have 10 raised to power 5 elements in the array, your computer would simply stop responding. Okay, cool. So now that we are clear with this thing, let's move on and tell me one thing. What do you feel? The answer which is expected, will that always fit into an integer, or can that overflow at times? Just think very carefully and tell me that. You guys already know what is an integer overflow and when that happens, right? Is there a possibility of overflow at all? So even if, let's say, there are 200 elements, there will be at least 2 raised to power this much values, and so basically these many integers will be there which you will be adding up. So you are adding so many integers, so many, literally so many. It is guaranteed that you will get an overflow if you do that. Does that sound good to all? Yes or no? Why overflow is quite possible over here. In fact, not just possible, it is going to happen for sure, because this 2 raised to power 200 minus 1 itself is going to be a value which you can't store in an integer. It's very, very huge, right? Okay, so the question gives you one relaxation. It says you that, okay, if you can't tell me the answer because it overflows, just tell me answer mod a particular value, 10 raised to power 9 plus 7. So it tells you that, hey, I am not interested in knowing the answer from you. I am interested in knowing the value of answer mod this. Okay. Now, whenever you take mod of something with m, then what is the result? What is the range of result when you take mod of a number x with m? Yeah, the answer lies in the range from 0 to m minus 1. That is the very reason question speaks about this. It says that, hey, do not worry about overflow. Just tell me answer mod this particular thing. Okay, now let us think, how can I maybe solve this question optimally? So tell me one thing. If I sort this array, will the output change? Will the answer change? Yes or no? Yeah, good. All of you are right. It will not change. Why it will not change? Because sorting the array does not have an effect on the subsequences that you generate. See, you did not change an element. You did not add an extra element. You did not delete an existing element. So those combinations that were written over here will be same, and because those will be same, the corresponding widths would also be same. So this is the most important part over here, that if you sort the array, the answer is not going to change, right? Okay. Now once you sort the array, then it will become very easy for you to visualize some patterns over here, and we'll understand that. Let's take a look. So let's say you had some array and you sorted them. You sorted the elements in that. So after sorting, let's say you got A0, A1, A2, A3, A4, A5 and A6. This is what you got after sorting. So the order would be like this. Okay, it will be in non-decreasing order. So let's erase that for a while. All of you understand what do I mean by sorting it. Now tell me one thing. Let us say you are talking about the subsequences. See, we are talking about the subsequences whose minimum is, let's say, A1. Okay, minimum is A1 and maximum is A4. Okay, so minimum is A1 and maximum is A4. It is guaranteed. Now tell me one thing. If your minimum is A1 and maximum is A4 in a subsequence, then what are the elements, what are the extra elements that can come in between? What are the extra elements that might come in between in such subsequences whose minimum is A1 and maximum is A4? So because I have already said that A1 is minimum, can you have A0? Can you have A0? Yeah, most of you are right. You can just have A2 and A3, right? Because once I said this thing, you cannot have anything greater than A4 which is in the right side of this, and you cannot have anything smaller than A1 because A1 is the smallest. So the possibilities for other extra elements in a subsequence that has A1 and A4 as min and max respectively is confined in this sandwich area, which is after index I and before index j. This is a very important point. Is that clear to all? Okay, good. Now can you tell me one thing, that how many different subsequences will be there which have A1 and A4 as their min and max respectively? So how many such subsequences will be there which have A1 and A4 as their min and max? Just think and tell. Do you feel it will be 4? Yes or no? The answer is yes, it will be 4. Why will it be 4? Let's understand it very carefully. Now everyone, please focus on the board. So the extra elements are like A2 and A3, right? So for A2 and A3, how many different subsequences of A2 and A3 are possible? In other words, how many different combinations of A2 and A3 are possible? So I can say there are 4 combinations, because if I try to build a combination that contains something out of A2 and A3 only, then for everything I have got 2 choices. 2 choices for this, 2 choices for this. So it is like 2 into 2, 4. So basically, the first combination is empty combination where I did not take anything. Second combination is where I just took A2. Next combination is where I just took this. And next combination is where I just took A2, A3. Now any of them, if inserted over here, will be something that will abide by the kind of subsequence that I am interested in, right? Okay, so now think of it in this manner, that if you insert this in between, then what you will get will be A1, A4 only, right? Why? Because it's an empty. You insert empty, that's like inserting nothing. Okay, when you insert this, then what will you get? You will get A2 coming in between A1 and A4. And it makes sense, because again this is a subsequence where minimum is A1 and maximum is A4, because A2 lies in between them. Similarly, if you put this, then you will get A1, A3, A4. And finally, if you put A2, A3, then you will get A1, A2, A3, A4. Okay, do these arrows make sense to you guys? Right? Yeah. So there are 4 varieties in this family. Which family? The family that has a particular min and a particular max. It has 4 varieties in that. Can I tell that the width of every member is going to be the same? What will be the width of this? What will be the width of first one, which just has A1, A4? What will be the width of second one, which has A1, A2, A4? That will also be A4 minus A1. Of this one, this will also be A4 minus A1. This one also. Isn't it interesting? The interesting point over here is that everything that belongs in this family will have the same value of width. Okay? Yeah, Imtiaz is saying how many times a particular width is in a subsequence. I guess not exactly that, but something of that form. So what do is you fix your min, you fix your max, and then you try to figure out that how many members will be there in this family. And a family has a particular width. So yeah, so basically you are on the right track, what you are thinking. So guys, what do I understand from here is that all of them will be having the same width, and the value of that width will be max minus min, which I have chosen. So it will be A4 minus A1 multiplied by the value 4. So I can directly add this to my answer. I haven't in a brute force manner considered these subsequences one by one. I just fixed my min, fixed my max. After fixing them, I knew that everything in that family whose min is A1 and max is A4 will have a particular width. And now if I'm able to figure out that how many members will be there in that family, then I can just multiply that with this, and then I can add that up to my answer. So is this point clear to everyone before I move ahead? This is the building block of the solution which we are going to discuss. The problem is not over yet, by the way. Okay, so now can we do it in a generic way? The answer is yes. Let's do it in a generic way. Let's say you have sorted the array, and after sorting the array, let's say you picked AI which is at index I, you picked AI to play the role of min, and you picked AJ to play the role of max. Now all those families of subsequences which have AI as min and AJ as max, okay, will definitely have a width of AJ minus AI. Now can you tell me how many members will be there in this family? So how many subsequences can be there of these many elements? Can you come up with that expression in terms of J and I? How many elements are lying in between AJ and AI? Again, let's take an example. You consider I equals to 3 and J equals to 6 and see what is that. Okay, so basically the first question that I asked was how many elements are there in this sandwich area? So the number of elements in this sandwich area is J minus I minus 1. You can take any example. You can take I equals to 3 and J equals to 7 and just check that. Does that make sense to everyone? How many of you have already checked that? That it will be J minus I minus 1. Yeah, some of you who are saying the answers, it will be like that. So if these many elements are there, then how many different subsequences will be there? The number of different subsequences will be 2 raised to power J minus I minus 1. So you can say that, hey, there will be these many subsequences of such a family, and for all such members the width will be equals to this. So if I multiply this value by AJ minus AI, then this is the contribution of everything that belongs to this family, and I can add this to my answer. This is the path that I can take. Look very clearly. See, if you understood this, there is no reason that you will not understand this. You will definitely do that. See, when you pick particular element as your min and a particular element as your max, then there are certain elements in between, right? Now, the number of different subsequences that you will have where this is your min and this is your max depends upon the fact that how many elements are there. So here there were 2 elements, let's say x elements. So the total number of subsequences or combinations of them is 2 raised to power x. The same thing is being generically told over there, that if A of I is supposed to be your min and A of j is supposed to be your max, then there are j minus I minus 1 elements in between. So there will be 2 raised to power j minus I minus 1 different combinations which can come and sit in between and still abide by this family. And all of them will be having the same width. So if I multiply this with this is the contribution of that entire family. Okay, cool. Now think of it in this manner. I can pick any particular starting point and any particular ending point. Okay, so let's say this is your array. You can pick any particular thing, let's say A of I, to act as your min and A of j to act as your max. Okay, now can I say that if this pair, which is my choice of min comma max, if this pair changes, then the subsequence that I will get, that will also change. What I mean by that is, if now I consider AI plus 1 to be my min and AJ to be my max, then the subsequences that I will be getting would be different. So every pair of min comma max that I choose, that would represent a family which is different from all the other families. Do you understand this part? Yeah. So I can say that, hey, now this question looks like very simple. All that I have to do is I have to fix a particular min, and for that min I have to check that how many max I can have. And the moment I have a particular min and particular max, then I can know how many elements belong in that family, because there is that sandwich area that will tell me that how many combinations can be there, and I can multiply that with the difference between max and min. So this is one way in which I can attack this problem. Now I am going to write the mathematical expression that I'll get corresponding to this, but that is the whole point. Fix every pair of min and max. And can you tell me how many different pairs will be there? Approx, if there are n elements and you are considering all the pairs of I comma j. So how many different pairs will be there? N square? In fact, it will be n square, right? Because let's imagine it like this. You have some array that contains A0, A1, A2, A3, A4, so on till an minus 1. Let's say you are first considering the families that has A0 as min. The families that has A0 as min, what are the different max values that they can have? Max can be A1 and then something can be in between. Max can be A2, so on and on. Max can be an minus 1. Correct? So if A0 is to be supposed as your min, your max can be anything from A1 to an minus 1. Is it clear to all? Right? Similarly, if A1 is your min, then your max can be anything from A2 to an minus 1. Do you all notice this thing on your own? This is a very important point to be understood. Okay, cool. So now let's try to solve this question the way we have understood. Okay, so I'll just take a very simple example over here. Let's say we just have 4 elements, A0, A1, A2, A3. Okay, now let us first consider the subsequences that has A0 as their minimum element. So first pair will be where minimum is A0 and maximum is A1. Okay, so if I consider such pairs where minimum is A0 and maximum is A1, then how many elements come in between? How many elements are in between A0 and A1? 0 elements, right? There are 0 elements in between A0 and A1. So how many combinations can be there? 2 raised to power 0 combination, which is like just one combination. So you can say that the number of subsequences that have A0 and A1 as their min and max will be 2 raised to power 0, because that is the gap. Correct? Similarly, if I consider that family which has A0 as min and A2 as max, A0 as min and A2 as max, can you tell me how many elements are there in between A0 and A2? There is just one element. So how many combinations can be there? 2 raised to power 1, which is 2 combination. So either that element will be there or that will not be there. So that family which has A2 as max and A0 as min will have 2 raised to power 1 members. Okay. Okay, how about the final family? What will be the final family? Final family will be that in which min is A0 and max is A3. What will be the width of that family? The width of that family will be this. And now you guys tell me how many different combinations will be there. How many elements are in between A0 and A3? So between A0 and A3 there are 2 elements. 2 elements. So how many combinations will be there? 2 raised to power 2. That is 4. So guys, see, I have considered all those families which could have had A0, A1 as their min max, A0, A2 as their min max, A0, A3 as their min max, right? Okay, similarly, I can consider all those families which have maybe A1 as their min. So if A1 is to be considered as min, can you tell me how many options do you have for max? A1 is min, so how many options do you have for max? How many elements are coming after A1? Just 2 elements are coming, right? Which are A2 and A3. So let's consider the case where your A1 is min and A2 is max. So where A1 is your min and A2 is your max, okay, in that case the width will be A2 minus A1. And how many elements are there in between? 0 elements. So how many combinations will be there? 2 raised to power 0. Let's move to the next one. The next one will be where A1 is min and A3 is max. So where A1 is min, A3 is max, in those families the width will be this. And how many elements are in between? 1. So how many combinations will be there? 2 raised to power 1. Is it clear whatever I have written on the board till now? You know, that's how you solve the problem. I mean, you just keep writing it down, and then immediately something clicks. Okay, and that is what is going to happen. So this is not over yet. Something is still going to click. Okay, now the final one will be that where my min can be A2. If your min is A2, how many options do you have for max? Just one option, which is A3. So if you consider the family where A2 is your min, A3 is your max, then how many options do you have? I mean, how many elements do you have in between? 0 elements. So how many combinations will be there? 2 raised to power 0. What will be the width of that family? A3 minus A2, and the number of combinations will be 2 raised to power 0. So this is a perfect triangular kind of thing that you have gotten, and whatever will be sum of this, that would be your actual answer. Okay, now let's do one thing. Let's look at this thing column by column. So let's look at the first column. Okay, some elements can be cancelled. We'll cancel that. Very good observation, by the way, very good. So let's look at the first column. Can you tell me what is common in first column? Can I say that in the first column the power of 2 is 0 everywhere? Yes or no? Look at this first column, the power of 2 is 0 everywhere. This column, power of 2 is 1 everywhere. This column, power of 2 is 2 everywhere. So do you see that in ith column, where my I starts from 0, the power of 2 is I. So you know, I can take 2 raised to power 0 as common, and then inside what I'll have? Inside I'll have this plus this plus this. And now if you take a close look over here, minus A1 will cancel plus A1. Minus A2 will cancel plus A2. So what will be left will be A3 minus A0. Here 2 raised to power 1 is common. Here nothing will cancel. Here nothing will cancel, but what you will get will be something like A2 plus A3. A2 plus A3 minus A0 plus A1. This is what you will get. And here 2 raised to power 2 is common. So what you will get will be A3 minus A0. So this is the simplified version of this triangular stuff that you are seeing on the board. Okay, now you know you can detect a wonderful pattern over here, and using that pattern you can solve the problem very easily. So let me tell you one thing. Tell me, when you are having 2 raised to power 0, then you are considering the elements like AI minus 1, right? Just see, A1 minus A0, A2 minus A1, A3 minus A2. So you are considering elements like AI minus 1. And that is the reason if you have AI over here, that AI comes here, so it got cancelled. Similarly, if you have AI here, that AI comes here, that is the reason it got cancelled. Do you understand it? Why the cancellation actually happened in this part? Yes or no? Right? Okay, and what is the pattern in second column? The pattern in second column is AI minus AI minus 2. See, this is 2 minus 2. This 1 is 3 minus 2. So the pattern in this column will be AI minus 2. Okay? Correct? Yeah. Good. It's like a sliding window. It's like a window of size 2. That's a very good observation. So here if you take a look, it's like a window of this much size. So first it was from here to here, and then it got slid. Now it is from here to here. That is the reason you have 1 and 3. Here it was window of size this much. So it was not 1, and then it was 2, 1, and it was like 3, 2. It's a great observation. Does that make sense to everyone? How many of you are able to sense this thing? Yes or no? Now let's talk about a generic case. See, I took a simple case so that you guys get comfortable. Now let's talk about a generic case. If I have a generic case, what will happen in that? So let's say there are n elements till n minus 1, okay, from a0 to an minus 1. What will be the first term? The first term will be a1 minus a0, second term will be a2 minus a1, then a3 minus a2. Can somebody tell me the last term? Will it be an minus 1 minus an minus 2? Yes or no? Because the last thing in the array is a of n minus 1, right? Good. So it will be an minus 1 minus an minus 2. And before this, you would have something like an minus 2 minus an minus 3. So now this cancellation is destined to happen. This n minus 3 will be gone from here, this will be gone from here. So only an minus 1 and a0 will remain. This is an important thing to understand. Only an minus 1 and a0 is going to remain. So let's say if you have an array like a0, a1, a2, a3, an minus 3, an minus 2, an minus 1. Then when you consider this first column, then with the power of 2, all that remains is this and this. an minus 1 is the left hand side and a naught is the right hand side. This is what remains. Okay, now let's talk about this column. So this column will be like, so first term is a2 minus a naught, then a3 minus a1, right? Then what will you have? a4 minus a2, correct? a5 minus a3, so on and on and on. You will have an minus 2 minus an minus 4, and eventually you will have an minus 1 minus an minus 3. This is what you will have in this column in generic terms. Does it relate to you? Okay, which terms will cancel here? Let's try to understand that. See, this a2 is gone, a3 is gone, a4 will also be gone, and so on and on. If you realize one important thing over here, what is happening is that if there is something, then that is getting cancelled by 2 units above it. See, here it was getting cancelled by 1 unit above. Here it is getting cancelled by 2 units above. So this will be also gone, and this will also be gone because 2 units above something will be there, and this will also be kind of gone because 2 units above something will be there. But what are the terms that you think will not be gone? So it is guaranteed that an minus 1 will not be gone, because see, for this to cancel, something has to lie 2 units below, and for this there is nothing 2 units below, and for this also there is nothing 2 units below. Okay, but for this an minus 3, 2 units below, this thing was there. So what you will be ending up with will be this and this. So it will basically be an minus 1 plus an minus 2 minus a naught plus a1. This is what you will have. Interesting, isn't it? Really interesting. So for this column, from here I have this much, and from here I have this much. Now you can do this exercise for the third column on your own, and you will see that what you will be left with will be this and this. So this an minus 1, an minus 2, an minus 3, their summation will be your left part, and this will be your right part. So now that we have understood this thing, we can apply it and solve the problem very easily. So what I would say is that the contribution of the 0th column would be something like this. It will be 2 raised to power 0 multiplied by an minus 1 minus a naught. Correct? The contribution of this will be 2 raised to power 1 multiplied by what remains from here is this an minus 1 plus an minus 2 minus a naught plus a1. The contribution of 2 raised to power 2, what will it be? It will be, from here you have an minus 1 plus an minus 2 plus an minus 3, and what do you have from here? You have a naught plus a1 plus a2. This is what you have, and this is how it would go on and on and on, right? Do you observe this pattern clearly, right? Don't you think now it has become very, very easy to solve? Because you can have a variable, you can have a left pointer. Left is just a variable which is pointing to index from here, and right is over here. So right is equals to n minus 1, and you have a variable, let's say prefix sum, and you have a variable suffix sum, and after each iteration what you are doing is you are increasing your prefix sum, and you are also increasing your suffix sum, and you are changing L as well as you are changing R. And initially you have 1, from 1 you can make 2, from 2 you can make 4. So basically in every step, going from here to here, going from here to here, and going from here to here is just a constant time thing which you can do. So you are maintaining 3 things with you: the power of 2, the prefix sum, and the suffix sum. And in every iteration you are multiplying the power of 2 by 2, you are changing your prefix sum, you are changing your suffix sum, and that's how you are moving on and on. Right? So it has been a long journey solving this problem, but I believe it would have been quite interesting for you. You would have observed that how we started from the brute force, and then we had that concept of, so let's connect the dots now, okay? Let's all do that. So we started from the brute force was exponential time, 2 raised to power n. So then we drilled down to the fact that, okay, even if I sort then the answer is not going to change, and probably that was the ignition point. Because if I sort, the answer is not going to change, and the moment I sort, I can fix a min, I can fix a max, and for that particular min and max, I know how many different families will be there, and all those families will be having the same value of width. So that's how I moved on. So I fixed my min as A0. In that case, my max could be A1, A2, A3. Corresponding to them, family lengths are written over here. And then I fixed my min to A1. Corresponding to that, my max can be A2, A3. And corresponding to them, the combinations are written over here. So this is a mathematical expression, and then some observation drilled it down to here. And when it drilled down to here, I moved there. Yeah, here, these are the things that will remain, these are the things that will remain. So we saw that, hey, something is increasing from here, something is increasing from here. And that's how we kind of solve this problem. Okay, I'll tell you one thing. When you just solve this problem, you have to keep one thing in your head, that the value of this thing might not fit into an integer, might not fit into a long also. So in that case, you have to write your code in such a way that every time you are taking a mod with the given value. So if the question asks you to take mod with m, so basically tell me the answer modded with this, then every time you have to keep on taking mod with this. So if let's say you are doing answer plus equals to x, then this is not sufficient. You should do answer equals to answer mod m plus x mod m and whole mod m. This is the rule of modular arithmetic, right? Yeah. So now you have the concept. Okay. Cool. So some of you who are new, I would say that Renaissance is basically about building the thought process to solve problems, because we strongly feel that it doesn't really matter how many problems you solve. Some people solve 500, 600, even 1000 problems, but they struggle in interviews. The reason is they haven't built such kind of thing that we have just done right now, okay? That taking iterative steps, building solutions one by one, and learning how to think. Basically training your mind how to think. That is the most essential step that you should do. And very soon, you would be seeing that apart from the topics of DS Algo, other topics also with the same kind of problem solving spirit would be released, wherein you will get to learn many other topics as well. Okay, bye and good night.